name is Soraya Sigsworth, and I work in the specification team at Green Tech with a particular focus on blue-green infrastructure. And today we're going to have a look at one of our newest solutions, which uses rainwater for irrigating those green areas. If anybody has any questions as we go along, there is a chat box to the right-hand side. If you just want to pop some questions in the chat box, we can go through those at the end. So some of you may have already heard of the word SUDS, Sustainable Urban Drainage. For those of you that haven't, SUDS are designed to mimic natural drainage processes by slowing down runoff, storing water and managing rainfall. On the right-hand side there, you can see the SUDS design guide is made up of 4 separate design pillars: water quality, water quantity, amenity and biodiversity. And traditionally in the past, when we've been dealing with these within design, we've not been very good at using all 4 of those. So we might be good at doing the water side, quantity and quality, but then not so good at also combining that with amenity and biodiversity. So we need to start approaching water management across all of these design pillars and coming together as organisations, be that landscape architects, engineers, communities, local authorities, and working together to create better management and reuse of water on a site. We also need to become much more circular in our approach. So on the left-hand side there in the picture with the trees, in the UK, we've been really good at capturing and disposing of water, but not so good at capturing and reusing. And given the way that climate is changing in our country and quite quickly, I think it's going to be really, really relevant that we start to actually utilise that rainwater. The value of SUDS is definitely becoming more recognised and more common sense. Now, those of you who are aware of SUDS and have been following their policy and legislation for a while may know that in June this year, the SUDS legislation actually changed slightly. We were hoping that they were going to make it mandatory, but unfortunately that didn't happen. So there were a few unhappy people because unfortunately when it comes to planning and design, SUDS is not a mandatory thing, despite the fact it seems to make complete common sense to be doing it. But there were some really positive changes to the policy. So for example, the main ones that we definitely are going to see coming through more in terms of our landscaped areas, there was a real focus on rainwater harvesting. We're really looking at source control now. So that means wherever the rain lands is where we're going to start dealing with it. Nature-based and green infrastructure was actually recognised within the standards. The 4 pillars were referenced, again, as mentioned on the previous page, so we can start linking in that biodiversity and amenity pillars. So all of these new changes to the policy and standards this year actually start to have a real focus on how we can deal with water in the landscaped environment. But why would we want to kind of do that? What benefits do we get from that? Well, we know, just like green infrastructure, when we incorporate SUDS and water management into our designs and our landscapes, we get the same benefits, but amplified. So health and well-being, obviously, is a very big one. We all learned during COVID how important green spaces are to us. And if we can utilise water management within these green spaces and keep them going for longer, that's only going to be a positive. Economics and tourism, cooler temperatures, cleaner air, reduced carbon, and of course the big one, flood reduction. So these are all benefits that things like green infrastructure give us anyway, but when we can tie them in with SUDS and water management, they're just maximised even more. So that's when we can start looking at things like sponge cities. So with more frequent storms, wetter winters, hotter summers predicted for the future, we need to use more innovative solutions from the ground up if we hope to create sort of safer, healthier, more sustainable communities. Sponge cities are designed to mimic natural processes, so a bit like SUDS, allowing urban areas again to store, absorb, purify rainwater and soak up water much like a sponge would. The concept was actually proposed in 2013 by Professor Yu, so it's not a new concept. Actually, almost you could kind of deem it quite old now. It's almost 12 years old. And he designed sponge cities as a way that urban spaces can work alongside nature to absorb rainwater as opposed to channeling it away. And again, the benefits to sponge cities are just like I've mentioned, the same as SUDs, the same as green infrastructure, but we're kind of combining those two things together. The big thing that these designing of these kind of sponge cities does is absorb excess water from flooding and storms. So a study done in 2022 showed that 1.8 billion people were affected by flood risk. Of course, that's worldwide, not just in the UK, but we are part of that world and we do definitely suffer with flooding in this country. And of course, that's only going to be exacerbated by worsening climate change and continued urban sprawl. It will support water supply because sponge cities absorb excess water. They can also be used to filter and sanitize and reuse the water, giving communities access to clean water in instances of drought. It improves the air quality. So again, they've done studies recently showing that air pollution from vehicle usage alone caused 8.4 million premature deaths a year. Again, that's worldwide, but that's a massive number, and that's just from urban, dense areas where we've got pollution from vehicles. And this can be combated by the incorporation of green spaces into our infrastructure. And then, of course, creating green spaces for communities. We all know how important that is. Urban planning now encourages closeness to nature because we've seen the proven benefits for mental and physical health. So sponge cities, as they're known as, offer a sustainable and innovative solution, and several cities worldwide are already utilising many of these benefits. There are lots of examples out there, by the way. If you just Google sponge cities, I'm sure you'd see lots of really good examples, but I'd like to share this one in particular. So this is Starry Sky in Shanghai. It's an area that covers 54 hectares, and 16 of those hectares are actually designated what they call water areas. So areas where they've actually combined water into their green spaces as part of the design. This started in 2014 after the sponge city sort of theory was developed. The original goal was to adapt 16 cities, and they actually added a further 14, and that was in 2016. So again, another great example where this is actually not a new concept and something other countries have been doing for quite a long time. Another really nice example is Rummelsburg in Berlin. I don't know if anybody on the teams has ever heard of Carlo Becker. So he was an architect, or is an architect in Berlin, who actually developed the Berlin Sponge City strategy. Again, if you give that a Google, there's some really nice, there's actually some really good videos, some nice pictures, and some of the design details out there too. And his exact words were that rainwater is too useful a resource to allow it to flow out of Berlin, and instead should be allowed to absorb into green infrastructure before evaporating, producing all the natural benefits. So, like I say, lots of different examples already out there in the world. But why would we want to use these kind of green things and nature-based solutions in our country? Well, studies now again have started to show, on average, nature-based solutions and infrastructure is 42% less expensive than traditional grey infrastructure, whilst also delivering 36% more value. Now, that study obviously looked at lots of different things like reducing the cost of build, install, and then things of like added benefits that it brings to the area. So boosted biodiversity, cleaner air and water, improved well-being. Lots of different ways that they assess this. But in the short term, they found that actually putting in nature-based infrastructure is actually a lot cheaper too. There's a very sort of big misconception and a mindset in the industry at the moment that green-based solutions are very expensive. But actually, if we do them right, especially if we incorporate our water, they do things like reduce maintenance costs. So we really start to see the benefits, not only from a, I guess, environmental point of view, but from a monetary value as well. Another really nice example, and this one is actually in the UK, is Castlefield Viaduct in Manchester. Excuse me. So this is actually a Victorian era 330-metre steel viaduct, obviously very high up in the sky, and it was completely derelict. So the Manchester Council and Natural England and a couple of other partners decided to transform this into a green sky garden. It's right in the heart of Manchester, and they turned it into a really beautiful elevated park with trees and plants and flowers, and just made it a really nice public breakout space for people to go. This is open to the public, so if you're ever in the Manchester area, you can go and visit the viaduct. It's a really beautiful space. However, one thing they didn't think about was how to irrigate it. So when they finished the project, they realised they had no way to get water up to the viaduct, and they had no mains water running to the viaduct. So they actually had to literally truck IBCs of water to the viaduct in order to water all the planting. So that got us thinking, how can we irrigate better? Surely there must be a way we can combine all of these wonderful things I've just mentioned into helping these kinds of projects. And that also then kind of nicely brings me on to the problem we have with drought and irrigation in this country. As I'm sure we've all seen, particularly this year, those of us who were on a hosepipe ban in the north. This is the Soil Water Index map, and this was taken in June 2025, so June this year. And what it shows us here is soil moisture levels across the UK and Ireland. So the blue areas show us where we have moist soil, and the brown areas show us where the dry soil is. And obviously the darker the brown, the drier the soil. So this year, there were more official drought emergencies called than on record. And that's official drought emergencies. And in the northwest, river flows during spring were the lowest since water level recording began. So not just the lowest since 19-something, the lowest since water level recording began, showing that we've got a real problem with drought in this country. And of course, for us in the landscaped environment, that means we've got a really difficult job in keeping all of our planting alive at the time of year when actually it should be thriving. But what we also know, and what again we've all experienced this year, and the data shows, that we're having more rainfall and flooding events. So we're seeing a huge decline in reservoir levels and increasing drought conditions. But we're also seeing increased flooding and really bad flash flooding events. So with water resources becoming scarce and increased risks from flooding, surely it's more important now than ever that we look at ways to incorporate harvesting and reusing that rainwater into our designs. Because surely, after all, that would make sense, right? And that's what then brought us on to Mona Pluvia. So it's a development from our original Mona tanks. So Mona, when we use it as a system on its own, we've had it for a long time, sort of 10 years plus we've been using Mona, and it gives us a really effective option for indirect irrigation. So it's an underground reservoir system that irrigates soil through capillary action. It sits below your planting media. It reduces watering frequency, aerates the soil, and is a direct benefit to the health of the trees and plants. Bear with me, we have to go through Mona first to get to the next stage. So each tank of the Mona has two capillary legs that you can see in the picture there, and they're backfilled with soil, and they reach right down into the water inside the tank. And there's a filler pipe and aeration covers as well. And those two capillary legs at either end of the tank give a really nice large area of irrigation. And it does that, as I just mentioned, using capillary action. What capillary action is, in very simple terms, because I'm not very good at explaining it, I'm not a scientist by any means, but it's a very simple natural process where water can move up through the soil. So we know the movement of water within the spaces of a porous material due to the forces of adhesion and cohesion. So what that basically means in simple terms is when the soil gets dry, the water will move up through it. When we use Mona tanks for this, we've done lots of extensive research, and we know under normal conditions, the radius of irrigation we get from that is 400 mil horizontally and then 150 mil vertically. So it wicks up vertically 150 mil. So as a rough guide, we get about 1 metre square coverage using one Mona 24 tank. So it's quite a good area just from one tank of irrigation. We got lots of different sizes. And these tanks obviously act as reservoirs, attenuating below the ground, reducing the maintenance needs. But they do all still require manual top-up of water, probably coming from something like a mains, a tap, for example. It's really adaptable and it can be linked together in runs, nice shapes to follow the landscape. So these pictures here kind of show a really nice example of how flexible the system can be and how it kind of looks when it's laid out. They're really popular and we use them really extensively actually on green roofs and podiums as well, which is where that would have linked in quite nicely with something like the Castlefield Viaduct project. But obviously they didn't have the mains, so how would we go about using that? And as mentioned before, the thing with manual irrigation is it still relies on a proper maintenance programme. So the trees you can see here, there were around 200 trees planted near the Olympic Park a few years ago. And during the really hot summer of 2022, one of my colleagues went out to visit those trees and could see that every single tree had an irrigation pipe, but none of them seemed to have been used. So again, that got us thinking there must be a better way we can utilise our Mona system to collect all this water that we get in the UK and use for our irrigation. And that's where we came up with Mona Pluvia. So in this rather crude graphic, you can quite simply see here, all we do with Mona Pluvia is we collect rainwater, for example, off something like a roof. That water is stored into an above ground, or it can be below ground if needed, but in this instance, we use an above ground tank. That tank then feeds the Mona systems underground. And right at the end of the system, we have a water level sensor. So as soon as the plants have called up for all the water and the tanks get low, the sensor calls back to a simple valve in the tank, which opens up and refills the Mona system. There's a couple of really nice benefits to doing it this way. When we use rainwater and we don't use mains water, there's obviously a massive saving implication there because we're not going to be paying for the water that we use. We're just reusing natural water, a natural source. We're also not wasting water, so it is a closed loop system. And what I mean by that is none of this water goes back into the sewer network. Of course, on the tank, there is an emergency overflow for if any reason we had an unexpected downfall. So if the tank gets too full, it can then outflow into the surface networks. But that's not what it's designed to do naturally and day to day. We also, when we compare it to traditional irrigation systems, are saving quite a lot of water because if we use something, for example, like leaky pipe irrigation, water is just consistently leaking out when it may not even be necessarily needed. And equally, again, the really clever thing about this is it's on-demand irrigation. So we're not just deciding as humans, like we would with normal irrigation systems, as and when we think the plants need watering. So, for example, we might decide that every Monday, Wednesday, and Friday, we're going to irrigate the plants at 10 o'clock in the morning and 10 o'clock at night, maybe in summer, regardless of what the weather's doing, the plants are doing, or what's needed. The water in the Mona Pluvia tanks will only be used when the plants need it. So again, we're saving saving water, we're saving on the cost for that, but we're also doing what's right for the planting and the landscaped environment. There are a lot of other add-ons we can do with Mona Pluvia as well. So for example, if we were going to do lots of different levels, we can add a pump. Obviously, it means it's a slightly bigger kiosk that we have to use, but that just means if we're doing lots of really different levels or a couple of football pitches in length, for example, and we need to make sure the water's getting right to the end, we can use a pump. We can also add liquid feed. So if we've got particular planting we know needs an extra boost in its first, establishment months, we can use liquid feed. And we can also add something called SEER monitoring. So that's, for example, I've had some good conversations with water companies who might be interested in looking at how much water we're actually using and saving and reusing. So lots of different kind of monitoring options that we can add to it. So all in all, it's a really simple but intelligent way of reusing our water to irrigate our plants. Now, we have actually set up a trial site in Crewe. We were a little bit late in the year in setting this up, so we didn't actually install it until the back end of August. So missed the main planting of summer this year, but obviously it's something that we can now track throughout the year and hopefully really see the benefits for. So we've got you can see in the top left-hand corner there, the kiosk with the tank in it and the control system. And then the install that we did, so the left-hand row with the terracotta pipework you can see coming out, that's the side with Mona. And the right-hand side has nothing underneath it. So that's just going to be watered traditionally by hand by the gardeners on site. They're all planted exactly the same planting scheme. So we mirrored the planting scheme down both rows. And we also used our topsoil in both sides. So we know that we're giving the plants completely same environment and a fair run on both sides. Literally the only difference, the left side has our Mona system in. Now, what was really interesting about this, I went to go and see the site last week. It is something that we will be more than happy to take people to. You're more than welcome to come and have a look. Obviously, at the minute, it's quite cold and the plants are not as particularly green as they would be in summer. But I was really surprised at actually just how much you could still see a difference considering that. So again, same setup. The left side is the Mona Pluvia side. The right side is just traditional manual watering. And hopefully, sorry, it's not the best picture. It really pixelated when I uploaded it. But you can see in that picture how the left side is considerably greener still. Especially considering this was last week. It was in the middle of end of November. And in fact, you can actually see there was a frost that morning when I went down. It was very, very cold. And you can see in the picture in the corners as well. So the left side is a particular plant. And you can see it's still got a lot of foliage on it. It's still very green. There's lots of leaves, whereas the one on the right-hand side had completely dropped all its leaves. And the more I looked, the more I could see this pattern throughout the planting on both sides. And interestingly, when we then looked at the data, so like I say, we are monitoring this site as well, just very simply in terms of when the water's being called for and how often, Mona Pluvia, despite the fact that we're in the middle of November, so a time when we perhaps wouldn't really consider watering our plants or even think about it, we kind of just let the rain do it. Well, I certainly know I do in my garden, which is terrible. But it's maybe when people would get a bit more lax about maintenance regimes, you can really see there actually there's something going on. And when we looked at the data, Mona Pluvia was still actively calling for water from the tank. And actually the weekend before I went, so not this weekend, but the weekend before, to site, it had called for water 4 times in one day. And that was just on a typical kind of chilly, cloudy day in November. And yet the planting is still calling for that much water, which really surprised me. And actually, I think is going to be a really nice side thing to monitor is how much plants actually need water throughout winter. And I'm sure there obviously will be a lot of horticulturists out there who probably know all of this already. But it's certainly really useful information for us to be able to share with people. So hopefully that in a very quick 25-minute nutshell is our Mona Pluvia system. Does anybody have any questions? Feel free to type away in the chat box if you do. We'll just give everyone a few minutes. I appreciate it takes a while to type. It's not as quick as being able to talk to someone. Okay, yeah, so we've had a question here. So does the system need mains power or can it be used in a remote site, please? So at the moment, it does require mains power. However, we are also looking with the sister company who makes the tanks and the kiosks for us at making it solar powered as well. So hopefully that might be a development that we can bring in next year. So mains powered at the moment, but we are definitely looking to also making it solar powered as well, because that would obviously help. For example, that Castleford Viaduct one, they did have electricity up there, they just didn't have water. But if I would imagine most standard Victorian viaducts wouldn't have electricity. So something like that with solar power would obviously have been a really good option for that. Anyone else? Okay. Okay, so I'll take that silence as a good thing. So that brings me to the end of the presentation today. It has been recorded, so if anybody wants a copy, please do let us know. And if anybody has any questions, please do feel free to drop me an email on anything to do with any of these systems. Thank you very much, everybody.